Welcome to John's Maths Book. In this video, we're going to be talking about compound interest and how it works. Let's look at an example. Let's say we place an amount of $1,000 in a bank account that pays interest at a rate of 10% per annum or yearly. Let's see what happens to it over 4 years. So if we start in year 1 with $1,000, so year 1, we start with $1,000. At the end of year 1, we get interest at 10%. So we take 10% of 1,000. So that's 100. So our money is increased to $1,100. In year 2, we start with $1,100 this time, because we've added the interest on. And at the end of year 2, we get interest at 10%. So at the end of year 2, our money has grown by $110 to $1,210. In year 3, we start with $1,210. And at the end of year 3, we have interest added at 10%. So 10% of 1,210 is 121. So at the end of year 3, our money has grown to $1,331. And then in year 4, we start with $1,331. And at the end of year 4, we have interest added at 10%. So 10% of 1,331 is 133.1. So our money has then grown to $1,464.1. So $1,464.10. As you can see, the amount of interest we receive increases each year as we're getting interest upon interest. So we get an interest on the interest we received on previous years. This is known as compound interest and is a very powerful way of making money. Although the method used here for calculating it is perfectly valid, it's labor intensive. As always, there's a quicker way. Let's have a look at the formula. So the formula shown here shows A is equal to P multiplied by 1 plus R divided by N to the power of N times T. So A is the final amount that we receive. So it's once all the interest has been added on over a period of time, that gives us our amount. So P is the principal or original amount. So in our example, the original amount was $1,000, or the principal. R is the rate of interest as a decimal. So our rate of interest was 10%. So in our case, R would be 0.1. N is how often we receive interest. So in our case, we received it every year. So this is, N in our case is 1 because it's annual. If we were receiving interest every month, then N would be 12 because it's 12 months in a year. If we were receiving every week, N would be 52 because it's 52 weeks in a year. And if it was daily, N would be 365 because there's 365 days in a year. And T is time in years over which we are calculating the interest. So now let's look at our example that we used to calculate manually and plug it into this formula and see if we get the same answer. So we have A, which is what we're trying to work out, is equal to P, so the principal. So we start with $1,000. So P is 1,000 multiplied by 1 plus, now the rate of interest was 10%. So 10% as a decimal is 0.1 divided by n. So how often did we receive interest? We received it once per year. So n is 1, and that's all to the power of n, which is 1 multiplied by t, so the time in years over which we're calculating the interest. So in our case, it's 4. So A is equal to 1,000. So we do our brackets first. So 1 plus 0.1 divided by 1. Now 0.1 divided by 1 is 0.1. So 1 plus 0.1 is 1.1 to the power of 1 times 4, which is 4. So if we now do the exponent, we have A equals 1,000 multiplied by 1.1 to the power of 4, which is 1.4641. So if we multiply 1,000 by 1.4641, we get A is equal to 1464.1. As you can see, the same answer, but a much quicker way of doing it. So now let's take a look at some examples. So using the formula shown here, let's calculate the compound interest in some examples. So the first one is calculate the interest received on $2,000 over 5 years if the interest is calculated weekly at 5%. So our final amount A is equal to the principal, which is 2,000 multiplied by 1 plus the rate of interest is 5%, so that as a decimal is 0.05 divided by n, which is, in this case, n is 52 because it's weekly. Interest is calculated weekly, so there's 52 weeks in a year, and that's the power of n, 52 times t. T is 5 because we got 5 years. So that is equal to 2,000 multiplied by, doing the bracket, we get 1.00096 to the power of 260. If we do the power of 260 of that number and multiply it by 2,000, we get a dollar value of 2,566, 2,566 and 72 cents. For example, number 2, calculate the interest received on $3,000 over 3 years if the interest is calculated monthly at 2.5%. So A is what we're looking for. The principal is 3,000 multiplied into 1 plus, and the interest rate is 2.5%, so that as a decimal is 0.025 divided by, that's calculated monthly, so there's 12 months in a year, so it's divided by 12 to the power of 12, because n is 12, multiplied by 3, because 3 is 3 years. So that equals 3,000 multiplied by, now the bracket part works out to be 1.00208 to the power of 12 times 3 is 36. So that is 3,000 multiplied by 1.0778, and that in dollars is 3,233 . $8.40. So for exercise 3, calculate the interest received on $1,000 over 2 years if the interest is calculated this time daily at 3%. So A is equal to the principal, 1,000, multiplied by 1 plus, and the rate of interest is 3%, so decimal 0.03. And at this time it's daily, so n is 365 to the power of n, 365 times t, which is 2. So that equals 1,000 multiplied by, now if we do the bracketed part, we get a value of 1.40822, and to the power of 730. And if we take that number to the power of 730, we get 1,000 times 1.061, $8,341. So in dollars, our final amount is 1,061 and 83 cents. So our final example is calculate the interest received on $10,000 over 6 years if the interest is calculated annually at 7%. So A is equal to, principal is 10,000, multiplied by 1 plus interest rate of 7%, so in decimals that's 0.07, annually, so therefore n is 1, to the power of n, 1 times number of years, 6. So that is equal to 10,000. The bracketed part works out to be 1.07 to the power of 6. So that's 10,000 multiplied by, and then 1.07 to the power of 6 is 1.50073. And if you multiply those two numbers together, you get, in dollar terms, $15,007.30. So that concludes this video on compound interest.